Hey guys, can you hear me? So I am on a new PC, so I had to configure everything for the streaming. I'm not sure that I am at 4K with my monitor, and I'm streaming at 1080p. So I hope everything is fine. I'm really not into this streaming thing. So yeah, I hope you can see. I'll try to zoom in a lot so you can see what is happening, and yeah. So let's start. I wanted to start by thanking Pinco Pallo for the donation. Thanks a lot. So in the last couple of weeks, I've worked on a lot of new nodes and also implementation of old technologies. I've worked on a new thing that I called ClipVision enhancer that we are going to talk about in a moment. So instead of doing a 1 hour long video that would take me like 2 or 3 days to do, I thought that maybe it's better to do a live stream. And yeah, if you have any question, don't hesitate to ask. So the first thing that I wanted to talk about is the ClipVision enhancer. So as you know, by now, ClipVision has a limit of 224 by 224 pixel. So our reference image, this one in this case, will always be cropped and scaled down to 224 by 224. That is a very small resolution, and so we can't get a lot of details out of it. What I've done already is the IPAdapter tiled. This node basically takes the picture, creates tiles out of it, and basically it is basically one IPAdapter per tile. So if you split the image in 4 quadrants, you will have 4 IPAdapters for each of them. There are the performance concerns. The result is not perfect. You need more conditioning to drive the composition because the single tile doesn't have the full context of the image. Each tile, at that point, the model doesn't know what the whole picture is, so it's not always perfect, and you need additional conditioning like a control net or whatever. So to try to squeeze more resolution out of the ClipVision, I tried this. I think it's quite new technique. It is still a tiling technique, but we'll see in a moment how it works. Let me run this workflow very quick. I have a TurboVision as checkpoint because it's a live stream. I want to go fast. But to make this kind of testing, it would be better to use a checkpoint, a standard checkpoint with more steps, because the model has more time to converge. So let me run this one. So this image here is what has been cropped. As you can see, this is the reference, but we can only work with square pictures. So this reference has been cropped to this image. So I'll show you this one later. Let's see the difference right away. So the one on the left, this one, is the standard IP adapter, and the one on the right is the enhanced version, basically. And as you can see, it's much better. It also, in the background, I don't know if you can see it on the stream, but in the background you can even see the JPEG artifacts that this new method was able to catch in the background. Probably there's some noise in the reference image, and it was able to catch even that. And also, if you can see the skin texture, it's a lot better. This is in the standard one is basically not existent. Also the dress, it's much better. Also this one was a watch, and here almost tried to make a watch, even it didn't succeed. This one is just a bracelet. So yeah. Okay, in this image here, I have basically simulated the tiling. This is what the model is going to see. All these tiles here, it's 4x4. And I used the image tile node to get this preview. The image tile node is a node in the essentials, and it's very useful. We'll talk about that later. We've already talked about this in a previous video, the basics, the one for the upscaling, but I added some nice options, some nice outputs that will help us, and we'll talk about that later too. So I wanted to show you nothing because it froze. Okay, here we are. I wanted to show you this picture here that is basically what the enhancer is doing. I hope to be able to tell you how it actually works. So the first thing that I do is to take the image and crop out the tiles out of it. In this case, I have 4 tiles, and the 4 tiles, each image is converted into embeds when it goes through the ClipVision. The ClipVision converts an image that we can see, that as human can see. It converts it into numbers that the model can see. So what I have at this point is basically 4 embeds, 1 for each tile. This is not going to work very well because, like I said before, the model doesn't have the full picture, doesn't have the knowledge of the whole composition, how the image actually works. So I take the embeds. The embeds is just a series of numbers. It's a one-dimensional array. So it's just a series of number 1, 2, 3, 4. I convert these numbers back into a two-dimensional array, and then I compose back the embeds, like you can see here in the middle. I compose back the original image with the embeds. At this point, with a series of techniques, I convert back this recomposed image into the original format that the IPAdapter can actually read, because the IPAdapter only reads the one-dimensional array. So I get back to that original format, and I merge this new embed that contains all the details of all our tiles. I merge it back with the embeds of the whole image. So basically, I have one embed for the whole image that gives me the composition, and one embed that gives me the details. Now, the size in this case, there are multiple sizes of the embeds. This is 1024. So basically, I have 1024 numbers to describe our image. So no matter how many tiles I use, so no matter how many embeds I have, they will be converted back into a 1024 embed. So I cannot put too many details into that. All I'm doing is basically giving like a microscope to the IPAdapter, to the ClipVision, and I give like a microscope, and so the ClipVision is able to catch more details. But at the end, even if I have 100 tiles, everything is compressed back to 1024. So do not expect miracles, because we have that limit anyway. I wasn't sure that this technique was going to work, but it actually does work, so I think it's worth giving a try. One last important thing is that these two final embeds, the one for the composition and the one for the details, can be either concatenated, so I can send them one after the other to the IPAdapter, and so the whole information is kept intact. Or I can average these two embeds. There's basically the first concatenation means basically it's like sending two images together. The average is like taking two images, average the result, and then sending all to the IPAdapter. I'm telling you this because now we are going to see how to do these two things. And it's an option that you have, and so it's important to understand what is going on. So this is a very complicated workflow that I've done. I can share this later, but it is actually very simple. I've added all this stuff that basically crops the image at the right size and so on. So since we are tiling images for the ClipVision, each tile will be 224 pixels by 224 pixels. And so it's important to scale down the image to the right size. So you do not use the prep image for ClipVision, because this one crops the image to 224. Instead, I use a simple math to do basically I multiply the number of tiles by 224, and that gives me the right dimension. We are going to rebuild this entire workflow, or at least part of this workflow, in a moment, so you understand step by step what is going on. And also, I think it's important because the simple math node has a lot of potential, and we've never talked about that. So we also see that. What else? Yes. So I've said that we can send both the embeds together, the composition and the details, or we can average them. To average them, we have the combine embeds. I can set average, and basically at this point I'm not sending details and composition separately, but I'm sending them together. There's not one that is better than the other. You just have to try. Let me check before going further. Let me check if there are any questions. What are you doing exactly on the merge phase? Let's see. In the merge phase, you probably mean this one. I don't want to get too technical at this moment. If you want to know exactly what is going on, it's the code is of course open source, and it's quite simple. So I think it shouldn't be too complicated to follow. But basically, it's a very common way of basically compressing data that is a sort of average, basically. It's often called pooling, and it's a sort of the average, basically. Normalized average. Are there any other questions? Let me check. Sorry if I don't. There's really a lot of things that I want to talk about. Sorry if I missed something. I'm always, of course, on Discord if after the stream you have questions. Will this live be archived? Yes, I will archive this one, and if it becomes too long or too boring, I will make a director's cut that will be smaller. Okay, let's. Yeah, since I wanted to talk about the simple math and also the tile node, that it's quite interesting. I think that we can very quickly repeat some of this workflow and rebuild some of this workflow. So we understand exactly what is going on. Okay, before doing that, I wanted to show you one other thing. That is this. There's this option called an enhance ratio. There's when you create a new ClipVision enhancer. Okay, these are all the options that. One is the tiles, the number of tiles. Usually it depends on the image, but it works between 2 and 4. It works pretty well. Also 5 sometimes. But again, you can't get blood out of a stone. We have 1024 numbers, and at one point it becomes useless to add more tiles because we simply cannot store them. And actually, if you put too many of them, since we are going to average all the information, we are going to lose a little bit of the composition, and the model doesn't know anymore what goes where. I hope that makes sense. Number of tiles. Of course, if you set a high number of tiles, you have to remember that the reference image has to be able to accommodate that. So it's if you have 4 tiles, the reference image must be 224 by 4. So another important thing is the enhance ratio. So we said that at one point we are going to average or concatenate the two embeds. The one for the composition is the one that usually the IPAdapter gets. So this ratio is basically how much of the original embeds, of the original composition embeds, we are going to inject. Why is this important? Basically, if I set this to 0, it's like not sending at all the composition embeds. This means that the image only takes details, no composition at all. This is important because if you have other kind of conditioning in your workflow, for example, for the composition you use, I don't know, a canny control net, or you have an additional IPAdapter just for the composition. You know that now the IPAdapter has the composition weight type, so you could use technically an IPAdapter just for the composition. So if you have any other kind of conditioning in your workflow, you can try to lower the enhance ratio. In this way, your detail embed will get a higher strength, so you will get more details. If you do not have any other kind of composition, like conditioning, like in this case, then it's better to keep a high ratio. In this case, 1. It means that the whole image, the composition image, and the details have the same weight, and we are going to lose some, of course, some of the details. But the composition, but the model knows how the whole image is done, and the image will be fine. In fact, if you see, we lost in the background, we lost some details, some of that noise that we had before, and also probably the face is slightly less detailed. But if I lower the strength of the composition embed like it was before, we also lost the watch. If I lower instead the strength, we get back some of the details. We get some nice details on the skin here. Okay, again, this is not a huge improvement compared to what we had before, but I noticed that sometimes it works. For example, if I have a picture like this that is already a close-up, and there are a lot of details already, the ClipVision is probably already able to do a good job with this image without going with the enhancer. If I prompt something like beautiful blonde woman with gray eyes wearing a white turtleneck, if I try now, probably there won't be a lot of difference between the two. Oh, okay. This is not image to image. This is all done with denoise 1. So we are not trying to replicate this image 100%. We are just trying to understand if the ClipVision is able to catch more details. So if we go here, so one thing that I've noticed is that the colors are 99% of the times better. I don't know why. I don't know if it's because the averaging of the single part, the single tiles, probably offers better a better evaluation of the colors. Probably is that. But yeah, it did a good job in both cases. Here on the forehead we have maybe just a tiny bit more wrinkles. Let's see the eyelashes. They are good. On the right was able to catch the slight smirk in her face. Also the hand is much better. But yeah, one thing that I noticed again is the colors are usually much better. This is very oversaturated. Maybe if I lower the CFG, yeah, I am at 2, I can try 1.5. This is a turbo model, of course. We get probably slightly better result, but yeah, as you can see, the colors are closer to the original. Okay, are there any questions? What's the difference between this method and an IPAdapter tiled? Basically it's the tile creates one IPAdapter for each tile. So each IPAdapter, each tile is independent from one another, and the ClipVision and the model is not able to understand the structure, the composition in its whole. With this method, instead, I try to the tiling happens in the embeds, and so I'm trying to recompose the image as it was at the beginning. So technically, this method should be better at least for consistency of the image. For the classic tiled IPAdapter is probably able to catch more details because I'm not going to pull the embeds, but I keep all 1024 numbers. So there's more data with the IPAdapter tiled. This method is doesn't cost anything in performance because our embed is 1024, and you can tile this image 100 times and the performance will be the same. It will take, at this node, it will take some more time to encode the image, but in the sampling phase, it's the same using 4 tiles or 100 tiles. It's the same, and it's the same in terms of VRAM. What if instead of recomposing all the embeds into one 1024 embed, we did a tiled one with also an added one for the composition? So yes, that is a very good question, and that is basically what you should do with the tiled. With the tiled IP adapter, the thing to do is to create the tiles. So use one tiled IP adapter together with an IP adapter advanced, and to the tiled IP adapter you connect your tiles. You connect, of course, your image. The tiles are created automatically, but the tiles are kept, the embeds are kept as they are. So you have, if you have 4 tiles, you have 4 embeds. At that point, you have a second IP adapter for the whole composition, and this will be usually low, like 0.5. That will help with the keeping the composition intact. This other method is very efficient, and it's better at keeping the composition. There are 2 options. You need to test them. It's very early. There's still some bug I need to iron. But I think it's worth to experiment with this, and I'm looking forward to your feedback. So let's try. I'll keep it here so I have a reference. Let me redo real quick this section so we understand exactly what is going on in this area. That is all what I wanted to clarify, because I hate when I see a video on YouTube and they start moving around the workflow and you don't understand what is going on. So I hope this is helpful. So the first thing to do is to get what is the shape of the output tensor of clip and IP adapter? Are they the same so that they can be merged by simply adding? Okay, we can talk about that, but maybe on Discord, in my Discord server, if we start talking about that, we never stop. We only talk about that. So I have all these notes here are because sometimes you do not have like the brown. Okay, you have this picture that is not a square, and we need to convert this into a square. So the first thing that I do is to get image size. The first thing that I do is to get the image size. I get width, height, and count. If it's an animation, it gives you the number of frames. Then I have a math node. Simple math. It's in the essentials. I connect width to A and height to B, and all I'm doing is to here I'm writing the formula that I want, that is mean A, comma B. This basically outputs the minimum between A and B, so the minimum size between width and height. Then I do an image crop, right? Image crop. You can use again the one in the essentials. I convert width and height to an input and convert the integer number to both, oops, not position, height. Okay. Okay, so if this image is 512 by 768, at this point I will the output will be 512. So I set a square, a crop area of 512 by 512. I set the position to be top left, so I get a square over here. If I do a preview, it happens nothing because I have to connect the image. If I do a preview, now I have my square image that if this is in portrait mode, it works both in portrait and in landscape mode. If I want the bottom or the center, I can just change the position. And now I have the center, but I want the top. Top center, of course, it's the same. You can also set an offset if you want, and it will add an offset to your crop region. Okay, so basically all these nodes do is to bring this image, being landscape or portrait, into a square. That's it, that's all. Nothing complicated. Then I am upscaling the image. I'm upscaling the image to, yeah, let's say, so I said that this is not an image to image, and it's not entirely true. It is an image to image with denoise 1. So the base image is completely obliterated at the end, but I'm sending in the very first frame, I'm sending the original image. So since I want a 1024 by 1024 image, I am using an upscale image. I set this to 1024 by 1024, and this will be our latent, our base latent, even though again it's the noise 1, so very little of this will be used. Then we need to go to the ClipVision enhancer. So I create a ClipVision enhancer. Okay. Let me move this here. So at this point, I have this square image, but I don't know what the size of this image is. So I know that I want, for example, I want two tiles. So the ClipVision is 224. So very simply, I need another scale image, and I set 1024 by 2 for 448, of course, connect the image, and I go to the image input. So in this case, Landscapes. Always remember to set the algorithm, the interpolation to the best one, that it's bicubic or landscapes. Never use nearest exact unless it's like pixel art. Developing a node that provides interactive region. Yeah, okay. Yeah, we'll get to that later. So at this point, I resize this image to the optimal size. It's not 100% necessary, but it's good practice. This way, the tiles will be ready to be cropped. Otherwise, you don't know the model. You don't know the node what is going to crop exactly. And this way, we know exactly what is going on. Since I want to be able to change the number of tiles to make multiple tests, what I can do is automate this. If I want, for example, 3 tiles, I have to do 224 by 3 and 672. But this is boring, and we have machines to do that. So let's make a machine do that. I'm using a simple math node that I only use as a variable. So this one will be the number of tiles, and I write 3 here. At this point, I convert the width and height to an input, and height to an input. I need another simple math and connect the first one, and all I have to do is write A multiplied by 224. At this point, I connect the upscale, and I also convert the number of the enhanced tiles to an input. Enhanced tiles to an input, and at this point I connect the number of tiles to it, and that's it. Okay, so this way I can change the number of tiles to 4, 5, or whatever, and these nodes will take care of scaling everything to the right size for us. Hey, Zijan, is it a problem? Should I remove the image? I'm so sorry. I didn't know it was a private image. Is it? Let me know as soon as possible, please. Or maybe it was a joke and I didn't get it. Oh, okay. Thank you. I'm really sorry I didn't ask you before, but I found this image in my hard drive, and I didn't know it was yours. So thank your cousin for all of us. So where were we? Okay. So this number of nodes all basically take care of making the image square, taking the right rescaling to the right size, setting the number of tiles, and so at this point we have the image at the perfect resolution for us. Again, it is important to understand that if you have the image must be bigger than the number of tiles multiplied by 224. If you have an image that is about like 512 by 512, you can only use it with basically 2 tiles. So for 2 tiles by 2 tiles, so 4 tiles total. Okay, let's see if okay, suggesting perhaps developing a node that provides interactive regions in feature on an image. So selecting the right section of an image automatically can be done with like segmentators, or yeah, so it can be actually done automatically without you having to select top, center, bottom, right, etc. But this is outside of the scope at the moment. So yeah, at this point we have everything ready, and all we have to do is to take, let me bring it over here, take our, I have VRAM to spare, who cares, let me load another one. So one thing that I want to clarify one more time, because I always get these kind of issues on GitHub. Here I'm connecting Plus model. When you use the unified loader, you never connect the ClipVision. You do not do this. You do not connect the ClipVision if you have the unified. Never ever do this, because you are loading the model twice this way. And maybe I should do better error reporting. I don't know how to fix this, because there are actually situations when you might want to do this, but 99% of the times you don't want to do that. So if you use the unified loader, you just connect the IPAdapter pipeline, nothing else. This is only useful if you use the legacy loader, the IPAdapter model loader. If you select your models manually, then yeah, you can select the ClipVision loader. At this point, you need both loaders. But if you use the unified, do not load another ClipVision. You are wasting VRAM. In the same way, the input in the unified loader is optional. You do not connect it to another model. This is another waste of resources. This is all you need. The input is used only if you use multiple unified loaders. So you connect them, you daisy chain them like this. But in the first one, the input is never connected, never. Hope this is clear. So we loaded the model. We have the checkpoint. Then we need to go to the latent space, of course. Connect the way. Let me copy this too. Positive and negative. Now it's all pretty straightforward, and you shouldn't have any issues. The thing that I wanted to clarify is the reason why we have all these nodes here. Anyway, let me finish real quick. I'm connecting the latent, positive and negative, the model. I'm sure I'm forgetting something, but we'll see. the code, the model, and the preview. It's a turbo model, so we set very few steps. I don't remember this one for what sampler is optimized. We'll go with DPM++. Oh yeah, that should be it. Let me see if I did something wrong. Again, don't do this. Don't use to load checkpoint that load the same model, because you are loading it twice. I'm doing this just for the sake of this tutorial. Yeah, that's it. Yeah, maybe I'll put the link to this workflow. There is already one workflow like this in the similar to this in the example directory of the IPAdapter. So if you want, you can check that one. At the moment, there is not all this mess with the math node, but I will make this available later. So before going to the next topic, let me show you something. We talked about the tile node. I'm using this just to show how the image is cropped, but I am not actually using this for the generation. So this is just for show. But since we have it here, again, we talked about this in the third basics video, and let me see. Yeah, and I use this for the upscaler to demonstrate, to show you how these upscalers work. But I added a lot of output that makes the whole process a lot simpler. So one thing that is important, especially when you do upscaling, is the overlap. So I can set a 25% overlap, and if I generate now, you see that I have the same number of tiles, but now basically there's a little overlap between them. At this point, if I want to recompose the image like it was before, like for example, at this point I can take the single tile, apply an upscaler, apply details, do whatever, in painting, detailers, whatever. And then I want to recompose the image as it was before. And that you can do that with the very nicely named image untile, for lack of imagination. So all you have to do is it takes an overlap X and overlap Y in the as input. You can simply convert those two into inputs and connect them to the overlap X and overlaps Y. I connect the image, and at this point, if I do a preview, of course I need the number of tiles. It has been cropped. There is 4. I could convert this into an input and then connect it to this node that contains the number of tiles. But just for simplicity, I'm setting 4 and 4. And now if I do this, I get the image back recomposed from this one. So this way is super easy to tile and untile an image. So, image to video. Yes, it is true that this this node, I haven't yet worked on video with this node, but Pom from Banodoko has done something cool. Okay, this animation here. Let me set a loop. So as you can see, the first one on top is the reference image. The one in the middle is the normal IPAdapter, the standard one, and the one at the bottom is the one with the ClipVision enhancer. And as you can see, we have a lot of details, but also again, the colors are much better, like I said at the beginning. But also the consistency, it's much better. Here in the middle, I have this thing that is dripping out, while here it's perfect. And so this technique actually works very well for animation. And I need to make more tests, but yeah, please, if you make some videos, let me know and show me the result, because I'm very interested in that. Okay, we talked about this. I showed you this. What time is it? Oh yeah, we are well over what I wanted. Okay, let's go. I think I wanted to talk about the sponsors, but at this point we'll do that another time. I don't want to. This is something we could talk about another time, but I just wanted to tell you this. That is, of course, it's only thanks to the sponsor, especially these companies, that I am able to release my code for everyone for free. I love sharing all my work, and the reason why I share the code is because I want the code, yes, to be used by others, but also I want that people in the field being able to see what I'm doing, and so they can help, they can implement and do maybe better, make modifications, and release back the result. This is the only way that we can evolve. The alternative would be me taking all this stuff for myself, making money out of it until I can, and there's no advancement, there's no discussion with the community. It just me profiting over something that I've done, and there's nothing wrong with it. Don't get me wrong. Why shouldn't I get money from something that I invented? But that is not how I feel. That is not how I like to work. I don't care getting rich. If I'm able to keep living, paying the bill with what I'm doing right now, with the little sponsorship that I'm having, I'm happy, and I prefer to share my knowledge and get less money compared that keeping everything for myself and maybe make a little bit more money. That's how I am. That's all. I have nothing against company. I have nothing against capitalism. Don't get me wrong. I just like it this way. So until there are companies that see the value in what I'm doing and sponsor my work, I will keep releasing stuff. So this is to say that I don't consider myself a YouTuber. I don't consider myself a content creator. My main product is my research and my code. On the other hand, if you are a company and you are taking my code, making modifications, and use the result for yourself without giving it back, you are a prick. You are really a low-level human being, really scraping the low-hanging fruit opportunist. If you make modification, the whole point of releasing this stuff is to improve the technology. This code is GPL3 licensed. It means that you can use it in any way you want. You can make money out of it. You can make money out of it, but if you make modifications, for yourself and for testing, do whatever you want. I don't care. But if you are a company, you do modifications and you make money out of it, you have to release what you are doing. Otherwise, why I am releasing all of this open source. One last thing, again. I really welcome and thank you for all the small donations. Every bit counts, of course, but I don't see freelancers, small studios, or hobbyists. You shouldn't be worried about using my code. Use it. It's open source. I'm happy even if you are making that extra money out of it. I'm happy. The problem is when the companies start to using the code, making a profit, and just give you the middle finger, basically. So the moment that I do not have sponsorship anymore, you are basically relying on my spare time or my willingness to spend my spare time on it. If I have sponsorship, I can keep doing what I'm doing. Okay. All this preface, all this introduction was because thank you guys for the donation. Really, really appreciated that. All this preamble was because since I have these sponsors and I am putting their logo and their name on the repository, I am kind of endorsing them, and I'm not. I don't know them. I know them because they are big companies, but I would like to know more about them, and so I started with the small one with Run Comfy, and not this time because it's a bit late and I want to show you more notes and this is boring stuff. I wanted to show you how it works and how it performs and what I like and what I don't like about it. I think that there's value on this. I will do this in another video. And please, this is not sponsored. This is not something that they asked me to do. They don't even know that I want to do this. So this is really my honest opinion. We are doing to do this another time because we are running a little late, and I want to show you more stuff that is more fun. Let me check if there are questions. We're happy. Thank you again, everybody, for the donations. Those go directly into making videos. Basically, the sponsors are for the code, and the donations are for the content creation that I am not particularly fond of, because it takes a lot of time, and I prefer to code than making videos. But I understand that it's important to share what you are doing, and videos is the best way. Can you please save this to your channel? I cannot find your previous live screen. Okay, yes, I will share this video, and if it's too long, I will try to take out the best parts. Again, thank you, Bruce. Thank you, Sambaldo. Thank you, Tobias, and everybody, Jimmy and Kryptonic. I'm sorry if I forget someone, but I really want to cover more road here. So the next node that I wanted to talk is about Kolors. Kolors is, probably you know about this already. It's this model trained by a Chinese company. It works both with Chinese or with English. It's it has a very good prompt adhesion, and the quality, the image quality is also very good. Okay, is the overlap between tiles still required since the new enhancer node matches the composition? No, you should not use overlap for the enhancer. And actually, again, the enhancer take care of making the tiles, so it will always make the tiles at the right size with the right parameters. Anyway, if you have more questions about the enhancer, please connect to the Discord server. I believe there's a link in the description, and I will reply to all your questions. Anyway, the only problem, so Kolors is a very good model indeed. The only problem that I have with it is a bit of the sketchy license, because it is based on SDXL. So it's not that they can do whatever they want with it. They have to maintain the SDXL license. And instead they did this thing that the Kolors are fully open source for academic research. For commercial use, please feel, etc., etc. I don't take my word for it. I am not 100% sure, but from what I've heard, and I talked with some guys at Stability AI, this kind of license, considering that this model is based on SDXL, it's not right. That it doesn't sound right to me. I need to explore better the situation here. Anyway, I am an academic. I don't care about at the moment. It is not true, but I don't care about the commercial side of things too much, even though it's not true, because I hate inside phase. And we are going to talk about another node later about this. But anyway, let's see the technical sides, and we'll let the lawyers figure out how the license work. But I wanted to point out this thing, that I am not sure that they can actually enforce this kind of license. being based on SDXL. So, okay. So Kolors is a very good model, impressive prompt adhesion. They trained the IPAdapter Plus to Kolors, and of course the node is, and of course it is already supported. So at the moment, you have to load you can load the models both with the legacy loader. So in this case, I'm loading the Kolors IPAdapter node and the ClipVision, or you can use the unified loader, but the community edition. So in the community, you have composition and colors. So in this case, the node takes care of selecting the right node, sorry, the right model. So another thing that is important, they trained the IPAdapter model over an OpenAI ClipVision, not on Lion ClipVision, not at 224. But at 336. In fact, in the name here, you can see patch 14 336. This is important because at this point, you do not use clip prep image for ClipVision, because this one at the moment only works at 224, and if you scale the reference to 224, you are going to lose resolution for this ClipVision. So we are going, so either you go straight into the IPAdapter, or you do simply an upscale. You upscale the image to 336 by 336. Okay. Again, very simple to remember because we have 336 in the name of the ClipVision model. So it is a very strong conditioning. So we have to play with the strength and often with the time stepping. Here I have this reference, and I basically prompt what this is: a fierce red-haired warrior woman wearing white and gold armor. If the image is in portrait mode, so you'll see probably something weird happening. Let's see. You'll see that the ClipVision, the text encoder will take some time because this is a large model. Finally, in the sampling. Okay, here we are. So, like I said, an incredibly strong conditioning. The image is basically almost one-to-one the original. What you see is that the image looks like stretched vertically. That is because the conditioning is so strong, and the original image is a square, but the latent is in portrait mode. So basically, the model is so strong that it stretched everything because the model really wants to keep the original reference intact as much as possible. So what we can do is, of course, lower the weight, and you need to lower. Yeah, that is too much. 0.76. You want to lower quite a bit to get not good result, but to being able to actually drive the composition with your text. Now it's getting better, but I still have to lower it a little at 0.5. Let's see if we can get less stretching. Okay, now finally it's more what we wanted. Maybe I can increase just a tiny bit. And really, I always liked color as a model, as a concept and everything. It has a very strong Chinese influence in the reference images, in the conditioning, but it's a very good model. But with IPAdapter, guys, this is killer. Really, the quality of these images is impressive. And if I take another like this one, I keep the exact same text of the fierce warrior woman, and it's really impressive, the quality and the definition of the face. There's no hallucination. It's really great. Let's try another one. Look at that. So there's another thing that you can do. Sometimes, for example, here I prompt white and gold armor with purple decorations. I don't get any purple decorations. I get white and gold, but no purple. Sorry, let me drink something. This is because, again, this is a very strong conditioning. What we can do now, I'm using linear weight type. Of course, we can choose style transfer or strong style transfer. Probably I can increase the weight now, maybe too much. Let's see. Instead of taking everything out of this picture, I'm only taking the style. The strong style is still not enough to give me the purple. Let's try with style transfer. The difference is that style transfer takes put the embeds only on one block of the unit, while the style transfer, the strong style transfer sends the embeds to multiple blocks. This image is amazing. We still don't have the purple though. We can try to start the composition at 20%. As you can see, we have some Asian Oriental conditioning. Let me try to go a little lower. Let's try 0.6. I really want to see that purple. Now I start to get some purple. Let me put this back to 0. Let me try to stop here. 45. We can also try with precise style transfer. Yeah, like I said, incredibly strong conditioning. Let's try with another seed. But anyway, I wanted to show you this because the quality of the images, it's really great. And Kolors together with this IPAdapter model, it's very, very impressive. And yeah, so this is another thing that I was working this week. Again, I'm looking forward to seeing your generations with this model. If you want, please share on my Discord, and let's see if there are any questions. Can this work with LoRa trained on SDXL? Since you said this is nice too. So everything has to be trained. For Kolors. You can try to send something. Even it kind of worked with also with the standard IPAdapter, but the models really need to be trained for Kolors, unfortunately. Would doing clip concatenate work? Clip concatenate for you mean for Kolors? Yeah, I haven't tried. We can try. I guess you mean conditioning concat. We can try to send this, and we can try to say purple decorations here. Oh, sorry. I need this, of course. Okay. Well, we get purple, so yeah, it works. Conditioning concat works. And probably so even also the other ones, the combine and average and whatever. Purple armor decorations. Let me remove. Let's see. Well, we got some purple in the armor, which is good, but there's also a lot of bleeding. Yeah, but yeah, all I wanted to do is to tell you about the IPAdapter models for Kolors, and it's worth a try. Okay, next. Next is, I don't know if you noticed, but I also worked on the precise composition weight type. So if in the IPAdapter advanced node, you'll find the composition, weight type, the strong style, style and composition, style transfer, precise, and now you also have composition precise. So I made this workflow to show you how it works and the difference between the standard IPAdapter and the precise composition. So as always, I'm using this image. I use this image because it's a very strong reference, because it has a very strong style. It's very strong art style. So I can very easily see if there's bleeding of the concept between the blocks. So in the prompt, I have portrait of the most beautiful anthropomorphic cat. The first one on top is the previous composition weight type. This is the standard IPAdapter with weight type composition. That was what we could do before. The image is fine. We took the model only took the composition of the image and not too much the concept, but there's still a little bit of bleeding. And you can usually see that, especially in the colors. There's a lot of bleeding in the colors. This image, for example, compared to this one, you can clearly see that this one took also the colors of the original image. Even though I think in the prompt I have bright in the text, so of course this one took better the concept. The token was translated better. So the second one, the second image instead is using the IPAdapter precise composition. And now we are going to check all the parameters. And as you can see, we still have the composition, but we have no bleeding of the colors. So the color, now we are free to prompt the colors in any way we want from the text encoder. The last one is the same thing as the precise composition, but it is done with the mad scientist, that is our beloved node. If you don't know, this one basically lets you send the weight of the visual embeds to each block of the unit. So in this case, what I'm doing, I select composite precise in the weight type, and all I'm doing is sending a weight of 0.8 to the third block and 0.35 to the sixth block. So all the other blocks are 0. Now it is again, I've already talked about this in a previous in the previous video about precise style. If you don't know about this already, please check the other video where I explain all of this. But the main the bottom line is that the third block in this case is the composition block. So this one is responsible of making the main composition without style, without anything. When you are in composition precise mode, the third block is sent as positive embed, and every other weight that you specify in the other blocks is sent as negative embedding. So in this case, I'm sending a weight of 0.35 to the sixth block. The sixth block is the style block, but this is not the weight of the embeddings. This is the weight of the negative embeddings. It basically it's like sending this image as negative input. Okay, I hope this is clear. So if I set, for example, layer 2 is also a very strong. It has some influence in the composition. So it is better to leave this alone at the moment, but for example, if I want, I can set layer 5 to 0.35. So in this case, both layer 6 and layer 5 will be sent as negative conditioning. So basically what it means is that I will get even less conditioning from anything that is not the composition of the image. So the precise composition node takes care of this automatically and does behind the scene some optimization. What I think it's the best configuration. With the mad scientist, you can build your own formula, basically. You can, the important thing to understand, to remember, is that the third is the main condition, the positive conditioning. Everything other weight that you set here with this syntax is sent as negative conditioning. So in fact, if you, this is 0.8, okay. If you see here in the IPAdapter precise composition, I have weight 0.8 that is the same as third block 0.8, and composition boost 0.35, oops, 0.35, which is the same as 0.35 in the sixth block. I can set this to 0.25. I need to drink. And if I set this to 0, I basically I should get very close to the original. Yeah. And sorry guys, as you can see here on the sides, I have these drawn like stripes here on the left and on the right that you can also find here because the concept bled into the composition. I have that kind of thing also here, but it's much better. So if you want to play with the precise composition node, actually with the precise composition in general, you can try the mad scientist, set the composition precise, and if you want, you can start playing with the numbers. And I can set layer 5 to 0.35, layer 6 to 0.35, and layer 7 to 0.35. And maybe I get even less bleeding. Of course, I've made some tests, but not. I haven't tested everything, of course. So this is precise composition. The same, we talked about precise style. Now I also have, sorry, this one. I also have a precise style transfer node that is basically the same as the precise composition, just for the style instead of the composition. So basically you have much less bleeding of the UNet blocks. What I wanted to tell you is that the boost cannot be too strong. If I set 0.5 already, it will be already very strong. And it's nice. It's still nice. But if I go to like 75, it will be probably all white or something like that. Because this image is taken as negative conditioning. And basically what... okay, all black actually. So what is this doing is making the opposite of what image is. So anyway, usually around 0.35 is fine, but of course play with it. And if I change if I change image, we should see. Yeah, okay, but this is cropped at the same. Let me take the warrior woman. Okay, let's try again. This should give me a kind of portrait on a higher distance. Yeah. And as you can see here, this kind of dress mimic the armor of the original, but in this one there is the standard composition, not the precise one. This got a real armor, so the concept of the armor actually bled into the composition, while in this one is less prominent. Okay, everything's clear. Having this mad scientist parameter as node is great. How can we determine boost and weight on these nodes? So you mean, the boost in this node is basically a preset that I baked for you. It's a formula that I found that works, and if you don't want to mess with the mad scientist, use these values. With the composition, the boost should be pretty low, but the weight can be around 0.8 is usually fine, but you can try with higher weight too. And all you have to remember is that everything except the third block is sent as negative conditioning. This is not Kolors. No, this is not Kolors. This is Proteus checkpoint. Yeah, Proteus. Ah, this is so cute. Okay, what time is it? Do we have time for one last thing? Yeah. Okay, I wanted to show you we can stay here. So I also worked on the face analysis extension, face, especially with the face segmentation node. Let me load Ferguson. Okay. The face segmentation is a pretty useful node for face segmentation. It's nothing special. The only good thing about it is that if you want, you can use dlib, which is not inside face, and it is completely free to use model. So you don't need the 10K license that you need for inside face, for commercial use, of course. This one is free to use, and I'm really trying to push the limit of this library to be able to use it in more useful ways. This segmentator can take the whole face, only the main features, that is eyes, nose, and mouth, can take only one eye, the other eye, the nose, both the eyes, and this can be very useful for detailers, can be very useful for swapping, can be useful for a lot of things. Again, I understand that there are very powerful nodes nowadays to do these things. There's live portrait, for example, there's reactor, in swapper, all this kind of stuff, but they are all based on inside face. So technically you can use them only for academic reason, for research. It's SDXL or 1.5. I guess you referred to the composition. The composition works with both SDXL and SD 1.5, but SDXL is much more powerful, and the blocks have a stronger meaning. Each block has a stronger meaning, so it doesn't work as well with SD 1.5. So does it align the face too? Yes, it also aligns faces. So we have face warp, for example, that can be used from this load image fishbone. This one be great, I get only the eyes. Main features, hold on, let me take this. Blonde, okay. This does basically, it's not a face swap. It basically takes the original the features and warps. That's why it is called face warp, and warps basically the image onto the other one. And as you can see, the result is pretty good. I can of course grow the features a little. Another little bit, and I can increase the blur. And at this point, if you apply a second pass, the result will be seamless. But the faces need to be more or less in the same position, otherwise it doesn't work that well. So I was saying also, this is quite unique to dlib. It also lets you take the whole face, not only including the forehead. Usually when you do a face segmentator, you get this thing. With this one, with this option, you can take the whole thing. But again, it's very useful because, for example, you can take just the mouth if you want to fix the teeth of an image, and you can grow a little the mask, increase the blur, and you are ready for a second pass. And of course, I export also only the segment, the section, and only with a preview, with a mask preview, I export the mask. So at this point, you can upscale this image to optimal size, apply a second pass, do whatever you want, and then you scale it back to the original size, and you can use this mask as to pass the image back into the original. You get also X and Y position of the mouth of the segment in relation to the original image, and you also get width and height of the segment. So this is, I think, very useful. And what I wanted to show you, though, is that load video. Let me take 16 frames. So I have this video. So what I've done is to add compatibility to videos. So now, oh yeah, okay. Now I can extract, I can make a segmentation with videos. Let me also take a video combine. So now I have all the frames ready for the animation, for whatever you want. Let me take this one. I don't need this. And I want to show you something. Yeah. So, and the same for eyes and whatever. Of course, I have the mask, I have everything. Again, this can be very useful, and now I'm going to show you something. It's important to note that as you can see, there's black padding around the image. This is because each segment can be of a different size, but image batches work at the same size. But this is not important because the mask that we are exporting is going to cut out only the mouth. So the black padding will be removed at the end. So I have this animation, this workflow that I've done. I'm going to run it and explain it very quickly because I think that we can wrap this up. This is a very simple LCM workflow for animate diff. With IPAdapter, I'm using this image as reference. What I'm doing is I'm taking the whole face of this woman, and I want to create basically a video-to-video, keeping as much as possible as the original facial expression. The problem with animate diff is that you lose most of the facial expressions. You lose like the blinking of the eyes, you lose the movement of the mouth, and in this case I'm doing a face segmentation. So I'm trying to reuse the main features of this woman as conditioning to try to keep a stronger facial expression. Now I'm showing you what I mean. This is the first pass. Of course, we are going to have multiple. I can check if there are questions now. I'm sorry for your voice. Yeah, I think that I'm going to drink something. Sorry guys, 1 second. Okay, nothing some water can't fix. Ah, better. Get the booze. Okay, so this is the first pass. Let me show you if. Okay, and this is the second. So what happens is that I'm using the reference image, the segmentation for the face as very strong conditioning, 0.9 strength and at 0.9, only for the face. So basically I use, I believe, a line art, yes. A line art control net only for the face. So the everything else is left to the model, to animative. And as you can see, there are some defects here in the animation. There are some strong lines, but I'm going to fix them with a second pass, with a light second pass, and it's not, again, with live portrait you can do a lot better with facial expressions. I understand that. But this is another thing. This is, again, IPAdapter, and it is using models that we can actually use. You can use this for video production, for a movie if you want, for a Hollywood movie, and give me some money back maybe if you do. But as you can see, we were able to keep a lot of the original mouth and eye movement. The blinking is very nice, and the mouth, we were able to keep a little bit of movement of the mouth. Also, you can see the tongue. So with this technique, we can use this segmentator for animations, and this is an option. I am not super skilled with IPAdapter. I bet there are better ways to use the models. I'm using a V3, I believe now. Sometimes V2 is better. I'm using LCM. I know that people use Hyper. I wasn't able to get good results with Hyper, so let's see what's going on here. Are you going to do an update video on prompt injection? Prompt injection. Yeah, what I wanted to do today, but it's too late. We will do next time. I want to take the okay, now it's frozen. I have to wait a few seconds. What I want to do is to take the Mad Scientist and try to send the same image to each block. That should give us a good idea of what is happening with the layers, with the blocks. At that point, we can use that data for the prompt injection too. Basically, oops. Let me take an empty. No, sorry. IPAdapter. Okay, this one. I want to take a Mad Scientist. For example, I can send this. For example, I can make an empty image with just green. Let me show you. This one basically just makes a green image, and I can send this as reference. Then I set linear, okay, and I send layer 0, column 1. This basically sends the green image just to the first block. In the prompt, I have close up most beautiful cat, which is I guess is fine. Let's try something simpler, like 3D render of an empty room, highly detailed 4K. Okay, let's try this. So as reference, I only have a green image. And as you can see, it had absolutely no effect. So if I send this image to the second block instead of the first, nothing happened. To the third, now something happened. As you remember before, I said that the layer index 2 has some effect on the composition, and now so we start to have an idea. So we know that layer 2 has some influence on at least the color and the composition, because we are sending basically a flat green image. So the model will do something flat and green. That is what is going to do here. If I set the weight to 2, so I double the weight, maybe we should get even stronger result. No, instead we got, yeah, it's okay. It's flatter. It is more. The result is more flat. But if I send the same to the third index, which is the fourth block in reality, now this is the composition, and I got a flat image. If I send this to the to index 6, that is the 7th, this is the style, and of course everything should be green. Yeah. So what I would like to do is basically create 12 generations. Now I'm doing only 3, and in each of them I set a different layer, like 5, and change the reference image every time and see what kind of influence we have on the final image. This is something that you can also do. And I would start with simple concept and then go deeper and deeper. For example, I can try to send the blonde woman to wall, and okay, and in the description I can write close up of close up of a person, high quality, detailed skin texture. Basically, let's see which if there's a layer that changes the sex or the gender of the person. This is, for example, yeah, this is the style. I forgot to put naked in the negative, but we've been lucky. Okay. Let's see. 3, for example, layer 1, let's see. We would need also to check basically the generation without conditioning, without the IPAdapter. That will give us an idea of what the model is trying to do. For example, here we have a woman. We should try to find a seed that generates a man and see which conditioning makes I can try with realistic vision. Let's see if we can get a boy, poor man. Okay, this is a close-up indeed. Anyway, this is the kind of experiment that I wanted to do. This kind of experiment would also help us understand what the prompt injection could be. I'm going to check if there are any more questions, and let's see if with face we get more. If there are more questions, okay. Can explain how the color code of empty turn into green. Oh, that is very simple, because basically we convert the it's the integer value of the color. We define the colors as usually from 0 to 255, but in reality that color is converted into an integer, and yeah, in this case 6 twos are green. The GPU is 4090. I've missed this, but where can I find the enhanced ClipVision? The enhanced ClipVision is in the latest IPAdapter extension. You have to upgrade. Remember to also upgrade Comfy, and that's it. How does the color work? Can you show us the usage of transparent background you added recently in the essentials? Oh yeah, this is a good one. The last one, actually. So in the essential, I have image remove background. Let's take this image, which is actually pretty good. Now you have to connect a model to this, and we have two models. One is the RAMBG model, and doing this twice, and the other is the InspireNet transparent background. This is the new one. The RAMBG is the old one. Use JIT means basically it's accelerated, GPU accelerated. If you do not have enough VRAM, or if you have a low spec GPU, you can disable this. Yeah, okay, same thing as the RAMBG. Here we have the providers, here we have use JIT. As models, we have 3 of them. Usually you want to use the base. The fast one is faster, of course, but it's less precise. The nightly is also nice, but a bit too much experimental. It does a lot of errors, but you can give it a try. So basically you use the same image remove background node, you just simply connect a different model to it. And we can try with a more complex image. Yeah, okay, the output here is a bit different because this one outputs an alpha image, but if we preview mask preview, we can preview the mask, you'll see that it worked. And we can do this image composite masked. Do we have the green? Yes. Let's do a green screen. We already have the green. Destination, image, mask, must be 1024 by 1024. And we go to the preview. And now we have the green screen. Let me show you with another image, load image. This one that is rather complicated. So let me put this and this. I don't know the size of it, so I don't know what will happen. Okay. So if we compare, you'll see that the new model is a lot better. Still not perfect because between the hair here, it wasn't able to catch this spot, but yeah, overall a lot better. We can try with another model. In the RamBG we have anime illustration, so this should do a better job. Not so much. Yeah, a little better. But as you can see here in the hair here, this one did a better job overall. Also over here, you can try with the nightly version. It's very aggressive. And now this was able to remove this section here, but if you notice in the shoulder we have some green, so it means that it removed some of the background there. So yeah, you need to test. Yeah. There are actually other nodes that I've worked on, but we are really running long here, so I think that we can wrap this up. Probably the most important is the image composite, that is this one, that is basically the same as image composite masked. The only difference is that this one works with animations. So this is useful when paired, for example, with the animation of the segmentator, because this node is able to do the composite back. Is free license. This one is MIT, I believe. The InspireNet is actually free. Is there a way to really have a transparent background around her face with a segmentator? And yeah, I think that this went 2 hours. Yeah, little over 2 hours. I am losing completely my voice, so I close it here. I wanted to cover a lot more things. Thanks everybody for the donations. I'm sure I missed someone. I hope this was of some interest. I don't like doing a lot of streams because I myself do not follow many streams. I sometimes find them a bit boring, but I don't know. Let me know what you think, if I should make more, if I should make them shorter or more frequent. I don't know. That's all for today, I guess. With the manager. Yeah, if you have more questions, you can find me on Twitter or on Discord. There are the links in the descriptions. If you need any of the workflows that I showed today, just let me know. Probably in the future I will add the link in the description of this video, but I can also post them on Discord. So yeah, thank you everybody for sticking with me for so long, and see you next time. Ciao, ciao.